Hello everyone. Let's start with physics of first year. So in this lecture series, we will have two goals. So what are our goals? Number one is to cover the content, the daily content of this course, and this will help you to pass the exams. And I would say this is a time dependent goal. Why this is time dependent? Because you pass your exam, you're done. The second thing and the most important goal of this lecture series is to grab the concepts behind this physics, and that will help you to pass entry tests. It will help you to understand the concepts of the larger fields or the basics of larger fields. So what are those larger fields? That could be thermodynamics, that could be nuclear physics, okay, that could be mechanics. These are all large fields that originate from this thing, and you will be able to understand the concept behind these fields. uh, I would make a comment here that if you are able to grab the second goal, then this implies that you have got the first goal also. But that does not work in this direction. It works in this direction. The reason is, if you got the concept truly, if you truly got the concept, then content is nothing. But if you are just running after the content and you are not grabbing the basic concepts, then this would not help. So I emphasize on this thing that in my lectures, please post your questions if you have any regarding the concepts, and try to grab the concepts. It will help you a lot, not only to pass the exams, but also to pass the entry tests, and also to help you in future, when you people are specifically working in the field of thermodynamics, in the field of nuclear physics, or in the field of mechanics. Okay, then let's start with the very first chapter of this physics, and this is measurements. I really like this arrangement. I'm sorry. I'm sorry, guys. My whiteboard is, yeah. So I'm back. So the first chapter is measurements, and I really like this chapter to be placed at first place. Uh, Remember, while you are solving the numericals, while you are reading the content of this physics, or while you are understanding this content, the units are most important part of physics. In every science field, it is most important part, but in physics, I would say that it has more weightage. You must understand that what units are going to transfer the meaning of physical things. uh, let's say there is a 1 liter of oil, or there is a 1 liter of milk. Then what does this 1 liter of milk mean physically? You must understand that thing. Or if the velocity have a unit of meters per second, then you must understand that what this unit means. 1 meter per second means that you are traveling a distance of 1 meter in unit time, or in 1 second. And what is unit time? Second. But if you are changing this second to, let's say, hour, then that conveys some different meaning. So That's why I would say that measurements are most important and basic part to understand that what you want to convey or what the person is conveying to you. That's why people mostly ignore this first chapter as they say that this is very basic. But I would say that this is the backbone of the physics, and you must understand the concept behind this chapter. Um, so after after depicting the importance of this physics, this first chapter of physics, let's start with the introduction of physics. So introduction. It is broadly classified into three major fields. One that deals with the extremely large things, and that could be universe, stars, etc. The second is extremely small things, and that corresponds to neutrons, electrons, etc. And the third is the intermediate, that deals with the intermediate things, and that could be things that we deal in our daily life. So I would say that daily life things, and that is mostly we are focused on. So this is very broad classification, and we'll explore these different things in this first year physics, but mostly we will be focused on this third one. And then what do you think, guys? What is physics? What is physics? Now we arrive. This brings us to the definition, a very broad definition. I would say a broad definition of physics. So physics. Remember two words. Uh, One is matter, other is energy. So physics is the study of this matter and energy. And what is this matter? Anything that has some mass or occupies some space. And what is this energy, guys? So energy is the ability of doing work, and we will define this work later on in some chapter. But currently you can just think of it that energy is just the ability to do work. We will explore on this term later on. And the mutual relationship between these two terms is basically physics. So that is a very broad definition of physics. We will see how this definition is applied in first year physics. In various chapters, we will see these things and their mutual relationship, and we will go back to this definition again and again. We'll revisit this definition again and again whenever we see the example of this thing, right? So keep this definition in mind, and these are the keywords. Remember these two keywords, matter and energy, and then their interrelationship is just physics. The next important thing is the physical quantities, right? Physical quantities. What are physical quantities? I would say base and drive. So that is first thing I'll write. So quantities could be base quantities or physical quantities could be derived quantities. The word derived is quite obvious. It will say that something derived, right? And base says something basic. If you remember your primary classes, think of it, our metric class, think of rainbow colors. 7 colors are basic, and then from those 7 colors you derive a large amount of colors. You see this colorful word, and all these colors are just the combination of those 7 basic colors, right? Same goes with this world of physics, where we have those basic units, right? And from those basic units you will derive the other units that you will use, and those derived units are called those units are called derived units. And what are those basic units? Base units, if you have a good concept of base units and how to manipulate them to get the derived units, then it would be very easy to get this term. Sometimes these derived units become complex because there are various base or derived units. Those are interrelated, and their interpretation become difficult. I will revisit this concept when we'll get to the examples of the derived units, but first keep this thing in mind that sometimes this interpretation of derived units become difficult and interpretation of base units become easy, and this is just because of the complexity that is added by the relationship between the base unit and derived units that are manipulating those derived units. So what are those basic units, or what are those base units? There are 7 of them. For length, it's meter, represented with m. For mass, this is let me write it apart. So this is the second one, and this is the mass, and we represent it with mass m, and its unit is kg. The third one is time, and its unit is seconds. The fourth one is electric current, or current simply, and its unit is ampere. And the fifth one is temperature, and its unit is, system international unit is Kelvin. Most often it's degrees in our world, but actually the SI unit is Kelvin, right? And the intensity of light, maybe you haven't heard this before, but this is the unit to measure how much light, how much intense light is. Most often on the light bulbs you have in your homes, there is a rating written on those bulbs that this is 15 candela or lumens sometime, and that refers to the intensity of light. Okay, so intensity of light, and its SI unit is candela, and we represent it with CD. And the seventh and the last term, which you most often use in chemistry, is the amount of the substance. Amount of substance, and it is in moles. It is in moles, and we write it like MOL. So these are the basic quantities, and the units associated with them are called the base units. But there are supplementary units also. And what are supplementary units? So probably you people have heard about the term radian. Let me first call it supplementary units. Okay, so maybe you people have heard about the radians. So what is radian? Let me draw it. So this is a circle, right? And this is an arc length. I would call it R. You know this is the center. This is the center. And you know from center to this point, this distance is also R radius, and this distance is also R. So if the now this what this is called? This is called sector. Now when sector is such that the arc length, which is this length, is equal to radius, then the angle theta, I would call it theta, or I would call, not to confuse, I would call it radian. So then the angle that is formed would be 1 radian, and that is not yet decided to be the system international unit or base unit, but it is the supplementary unit, and it is most commonly used in mathematics, in geometry, and other related fields. Now let's look at the second supplementary unit, that is steradian. And so let's consider it a sphere, and to show it like sphere, let me, okay, so let's consider it a sphere. Maybe that's making a bit sense now. Let's consider it as a sphere, and now we can say that if this is now area, and if this area is equal to r square, and r is the radius, where r is equal to radius, if you take the portion of this solid cylinder, if you cut out the cone from this solid cylinder that has this base area equal to r square, where r is the radii of circle, then this solid angle, which is now this angle, should be 3D. You can imagine it like a cone. Most of time, children make a cone from the paper, so think of it like that. Then the angle that is subtended at the center of this cone is basically steradian, right? So that brings us to the definition of steradian and radian. Let me do it on this page. It will make mess, but it will be helpful for you people to have the definition on the same page. So one radian is the angle subtended at the center when arc length is equal to r, right? So interpret this unit like this. See, this is the angle which is subtended by the arc that has radius equal to what? That has radius equal to r and arc length equal to radius, right? So keep this thing in mind. And for the steradian, it's quite simple, but now you are just talking about the subtended surface area instead of the radius, and you can say that the angle subtended by the cone instead of now circle. The angle subtended by the cone by the area, which is equal to the r square, right? So these are two supplementary units. And let me make a comment here. So I'm sorry about that. So I promise you guys that 80% of the time, 80% of the time, this definition comes in the exam as a 2-mark question, right? So remember, it's important for you to remember as the goal of the content, but it's also important for the concept. So this is quite important slide, and you people need to remember this thing. Uh, as I promise you, I'll discuss one thing regarding the complexity of the derived units, how these are complex, to interpret. Let me go through that. So let's say take a unit of force, right? Or let's start with a simple one. Uh, let's do it with electricity, right? So remember, I told you the unit of the current, which is I, is ampere, right? So this is base unit. Now let's jump from base unit to the derived unit and consider electric charge, right? Electric charge. So electric charge unit is coulomb, represented by C. How this C comes? C equal to amperes second. So charge is basically how much current is passing in a unit time, right? So its unit is amperes second. Now think of it. This is charge 1, and at time is equal to 0, right? And then this is the area, and this charge passes through this area in 1 second. 1 second. It crosses that area in 1 second. So I would say that the charge that is the electric charge that is passed through this unit area in 1 second is the electric charge, and that is equal to 1 coulomb, right? So keep this note in mind, and let's see a unit of pressure. Its unit is Pascal, and that is given by Newton per meter square, which is equal to kg meter per second. If you are taking this lecture, if you are listening to this lecture just for the sake of content, then might be this slide is not important. But if you are listening this lecture for the sake of the I'd say for the sake of concept, then this is very important. So see, for the if we look at the unit of this pressure, this is Newton per meter square, which says that 1 unit of force applied per unit square area, per unit area is already unit of square, so per unit area. So if you apply 1 Newton force on an area of 1 meter square, then it would be 1 Pascal. If you apply a force of 1 Newton on a 2 meter square area, then the pressure would be 0.5 Pascal. And if you apply a force of 2 Newton on a 1 unit square area, then the pressure would be how much? 2 Pascal, right? So that is important uh, to understand. But if you translate it to the base units, that is kg per meter per second square, right? So now you have got three terms, 1, 2, and 3, right? So to interpret these three terms, it now again become a little difficult from this interpretation of this single term, right? So that is the intuition behind the comment I made, that when you go from base units towards the derived units, their interpretation becomes little bit difficult. This Newton per meter square is easy to interpret, but this kg per meter per second square is little complex than this one. So that's why moving from the base units to the derived units will make it difficult to interpret. But if you are able to understand that what the base unit is representing there, or what it is, then it will help you to understand these derived units. And later on, trust me, most often, 80% of the time, you have to deal with the derived units. So spend a little time on this thing, and it will make your life easier. It will help you to understand the how to interpret the derived units, and then it will be easy to grab the concept behind the numerical problems and the other things. So let's move to the last topic of today then, and that is the scientific notation. Scientific notation, that is not really a big deal. It's just representing in terms of powers of 10, right? Let's say I have a number 134.7, right? And I want to represent it in the form of scientific notation. What I need to do is I want to move this decimal to this place. Always remember, decimal should be one digit to the right, one digit to the right of non-zero digit. So this is your first non-zero digit, 1, and your decimal should be placed here. So it will make this term 1.347, right? And how much units to you moved it to the left? 1, 2. Okay, so you will write it like 1.347 into the number of places you moved it to the left, 10 raised to the power 2. But if this number was, let me go the other way around, if this number was 0.01347, and now I want to convert it to the scientific notation, then I want to move this towards this side, and here, and then here. So how much? It's 1 and 2. I need to move it 2 units toward the right, and if I want to move it 2 units toward the right, then I will write it like 1.347, but into 10 raised power 2, but you will write minus with that term, right? So if you are moving from left to right, then you will add a negative power. Okay, and if you are moving from right to left, then you will add a positive power. With that, we'll call it a day. Revisit this lecture, see the concepts. Let me know in the comments if you have any question, and I'll respond you back. I will be posting the notes along the video. You can see the post, the notes in the description, and do like and subscribe my channel. See you with the next video. Thank you very much.